Test. Okay, this is taking a look at example number 1 out of section 10C in your book, using a sine wave to model some real-life data. So for this data set, we're given temperatures for a given city for the months January through December of 1 year. And they also tell us that just to assume that January equals 1, February equals 2, and so on. So 1, 2, 3, 4, all the way up to 12, the 12th month, December. To find a model in this form, to find the amplitude, just take your maximum minus your minimum value and divide by 2. We get about 6.5 when we do that. To find the period, and we're expecting that the hottest temperature happens about every 12 months, every July, or the coldest temperature happens about every 12 months in February, so the period here is 12, and you have to apply this equation in order to find that value. When we plug 12 in for the period, we come up with pi over 6 for the value, the parameter b. The vertical shift, just take your maximum plus your minimum value. It's the average or the middle, halfway between the maximum and minimum values. You get 20.5 when you do that. Now lastly, for the horizontal shift, the regular sine curve starts at 0. We can see that this is dipping down to 14 and then coming to a maximum at 27. The sine curve typically goes up to the maximum first, then down to the minimum. So I'm expecting, if I could slide it over to about here, about 4.5. So you can get that value just from looking at the data or just from kind of looking at the points. How far do you need to slide it left or right? A more rigorous mathematical approach, since you have all the other parameters, A, B, and D already, plug those in. We've got A is 6.5, B is pi over 6, and D is 20.5. And just like finding the equation of a line, if you plug in a point on that curve, you can solve for the other unknown. So if I plug 3 in for x and 15 in for y, solving that equation, and you can pause this if you want to follow through the algebra in a little bit more detail, come up with about 4.9. So if we want to use technology to check this, go to your graphics calculator, press the stat button to enter any statistics. You want to edit the lists, and in the left hand column I've entered 1 through 12 for my months of January. In the right hand column I've entered the temperature each month. To generate a scatter plot, press second y equals where it says stat plot, and if this isn't turned on, you'll need to make sure that the plot 1 is turned on. In order to do that, just hit enter and you can highlight on. I do want a scatter plot, so this one's highlighted. List 1 is my monthly data. List 2 is my temperature data. And if we go to our graph, typically on a standard window, you're just going to have this. This is the negative 10 to 10 axis. Okay. If you press zoom and scroll down to stat, zoom stat, this will adjust a nice window for you. And I've already entered in the model that we'd found here. The graph is showing us each of the data points, and in fact, once we found all the parameters, it turns out that this model is a pretty good fit. So this is just an example of how you can use your graphics calculator in order to check that you are finding a good model to fit your data.